Welcome to this explainer. If you're someone who loves peeling back the layers of the tech we use literally every single day, you are in exactly the right place. Today, we're tearing down the staff-level machine learning system design behind personalized notification ranking. We're talking about the massive AI architecture that giants like Meta, LinkedIn, Uber, and DoorDash use to decide exactly what, when, and how to ping your device. Just think about your phone screen for a second, right? Why is it that some apps just seem to possess this magical, uncanny sense of timing, hitting you with a ping exactly when you need it, while others just absolutely spam you with junk until you finally get fed up and uninstall the whole thing? Well, that stark contrast is definitely no accident. It's the result of highly sophisticated AI. So today, we're going to reverse engineer how these companies maximize your long-term engagement without, crossing that line into annoyance and driving up the massive business cost of user churn.
Okay, let's dive right into this. First up, we'll look at the notification dilemma. Then, we'll uncover the incrementality secret, walk through the high-level architecture, break down features and fatigue controls, and finally, put it all into production.
Section 1. The Notification Dilemma, Interruptive by Design. To really grasp this system design, we have to recognize that ranking notifications is fundamentally different from ranking a typical social media feed. When you're scrolling a feed, you're already in the app. You're a captive audience. But notifications? They are an interruptive medium. They literally reach out and grab your attention when you're probably busy doing something else. And because of that interruption, the cost of a bad ping is incredibly high. It causes annoyance, leads users to turn off permissions, or worse, triggers a complete app uninstall. Every single send or no send decision is just incredibly high stakes.
Section 2. The incrementality secret, causal value.
So the absolute crucial point here is understanding this concept of uplift, or incrementality. A novice machine learning engineer might just try to build a model that predicts, hey, will the user click on this? But the senior level framing is totally different. Think about it. If you send a ping to a user who was literally going to open the app anyway in 5 minutes, that notification has zero true causal value. Actually, scratch that, it has negative value, because you've just annoyed them for absolutely no reason. The AI has to measure the causal uplift, the actual difference in behavior caused only by the decision to send versus not send.
If an AI system simply optimizes for raw opens, it's going to end up spamming your most loyal, already engaged users, while simultaneously burning out your marginal users until they just churn entirely. By contrast, optimizing for uplift makes sure the system only sends an alert if it will genuinely change behavior for the better. The true objective here is causal incremental value minus the long-term cost of fatigue. That is what actually keeps a communication channel healthy over the long haul.
Section 3. High-level architecture, the system flow. Let's trace the complete flow of a candidate notification. Notice how we start on the top left with a huge pool of potential notifications. From there, each candidate passes through the value and uplift model, which checks in with a database storing the user's current fatigue state. Then it moves right along into the send time and channel optimization block, before finally hitting that decision and caps optimizer, which makes the ultimate call to either send it or suppress it. Breaking down those steps a bit more. Step 1 is the scoring phase. This is where the uplift model predicts the true incremental value of the notification. Once we have that score, step 2 determines the when and where, finding the optimal send time based on when you're historically active and picking the best channel, like a push alert versus, say, an email. Finally, step 3 acts as the gatekeeper. The caps optimizer applies strict mathematical limits, maybe a hard cap of 3 notifications a day to enforce fatigue limits and make that final send or suppress decision. Section 4. Features and fatigue, controlling the volume. Looking closely at the crucial data sources, you've got your candidate store providing the actual supply and send logs tracking the outcomes. But you really want to pay special attention to the holdout assignment. To calculate that causal uplift we were just talking about, the system absolutely has to rely on randomized control groups. It randomly suppresses notifications for a small percentage of users just to establish a causal ground truth. Without this holdout data, the AI is just flying blind. We also have the fatigue state, tracking exactly how bombarded you've been recently. When we drill down into the specific ML features, we start seeing groups that map directly to human behavior. User engagement tracks how often you're opening the app. Notification relevance looks at the topic. But fatigue state is where it gets super relatable. This translates complex ML into a very human concept. How annoyed are you right now? It counts the volume of recent sends and checks if you've been swiping away or dismissing alerts lately. The system also calculates historical risk, predicting your overall likelihood of unsubscribing entirely. The source material offers this fantastic quote that really hits the nail on the head. It notes that fatigue features, like recent send volume and dismissed behavior, are absolutely essential. That's surprisingly easy for engineers to forget. If an engineer is just tunnel-visioned on how clickable a message is, they completely miss the bigger picture. Fatigue features have to be paired with a churn or unsubscribed risk model so the AI can accurately weight the long-term cost of annoying you today against the short-term value of getting your attention right now. Now, what's really interesting here is the actual production math equation used for this final decision. The total value of a notification equals the predicted causal uplift minus the fatigue and unsubscribable risk. See that little lambda symbol in there? That is a tuning parameter. It literally lets the business turn a dial. If they crank lambda up, the system becomes highly protective of your attention, strictly minimizing fatigue, even if it costs them some short-term engagement. Section 5. Into production. Scale and serving. Handling this at the scale of a massive tech platform requires a dual-path approach. On one hand, you have batch sweeps. These are scheduled optimizations running periodically, say every few hours, scoring millions of standard marketing or content pings and lining them up perfectly within a user's daily budget. But then you have real-time triggers. Like if you order a car and need a "your ride is arriving" alert, that obviously cannot wait for a batch process. The system instantly scores these time-sensitive alerts and blasts them through the fatigue gates immediately. But operating at this kind of massive scale comes with some really strict warnings. The system's own success creates selection bias, right? Because the AI is only learning from the notifications it actually chooses to send. This just reinforces how absolutely critical it is to maintain those randomized holdout groups to get unbiased data. Plus, keep in mind that privacy rules, user consent, and regional marketing laws act as hard, unbendable constraints at the very end of the pipeline. They will completely override any fancy AI decision. So, we've seen how today's systems master the incredibly delicate balance between engagement and annoyance, using causal uplift and strict fatigue penalties. But looking forward to where these systems are evolving, it leaves us with a pretty provocative thought to chew on. What happens when the AI stops looking at just today's budget and starts using reinforcement learning to plan a long-term reward policy for your notifications months in advance? It is a truly fascinating frontier in machine learning. Well, I hope this explainer gave you a clear, structured look at the incredible engineering deciding what pops up on your screen. Keep learning, and I'll catch you in the next one.